Hey, Algebra 1 students, Mr. Fovel is back, and I'm looking at lesson 6-8 of the IM. And in this one, we're going to be looking at equivalent quadratic expressions. So the best way to kind of start with this is to understand the area of a rectangle and how that can help us with multiplying quadratics. So if you look here, I have two math problems of 5 times 24 and 29 times 15. Those are going to help us with understanding how to do quadratics, such as x times x plus 3 and x plus 2 times x plus 6. If you remember, the area of a rectangle is length times width. So we're going to look at those situations now. First, we have 5 times 24. If we draw a rectangle, we can split this into two sides, your length and your width. The length we're going to say is the 5, and the width is 24. But to do this, we're going to try and make the math a little bit easier. So we're going to break the 24 into two parts, 20 and 4. Now these are added together. Addition is not a big deal because all of the numbers are positive here. So if we multiply 5 times 20, we get 100. And then we're going to take 5, because that also represents this side in here, times 4, which is 20. So we have the math problem 100 plus 20, which is 120. Okay? Notice that multiplication with area gave us a very simple situation. So we're going to use the same idea with this quadratic here. We make our rectangle, and we split it down on one side because there's two numbers here. We only have one number here being x. Here we have x and plus 3. So we take x times x, which we know is x squared. We take x times 3 because this side is x. That's going to give us 3x. Then we write this in standard form using addition, and we'll get x squared plus 3x. So we know that x squared plus 3x is the same as x times x plus 3. Okay, let's look at a little bit tougher problem. So we'll start again with just basic multiplication. We're going to create our rectangle. This time, because we have two two-digit numbers, we're going to split both sides into two parts. 29, we're going to split into 20 and 9. 15, we're going to split into 10 and 5. Now, this box in here is made up of 20 and 10, so that's going to be our 200. This box right here is a 9 and a 10, so we're going to get 90. This box here is a 20 and 5, so we're going to get 100. And this box over here is a 9 by 5, which is 45. Then we can add all of this up for 200 plus 100 plus 90 plus 45, and we'll get 300 plus 90 plus 45, which is 390 plus 45, also known as 435. Kind of a long way to do multiplication, but it will help us with a simpler or a harder version of quadratics. So again, we're going to split this one into two parts. There's an x and a 2 and x and a 6. We need two parts on both sides. So x, and then we have the positive 2, x, and the positive 6. This creates x squared. This creates 2x, 2 times x. X times 6 is 6x. 2 times 6 is 12. And then we write this out as an addition problem. X squared plus 6x plus 2x plus 12. In this, we have two like terms in the middle. So we get x squared. Positive 6 and positive 2 make positive 8x as you add them, plus 12. And we know that these are equal quadratics. Hope this helps you in the long run. If you need to rewatch the video, please do so.